Hello, everyone. I am Jiebo from the University of Rochester. Today, I'm going to talk about intelligent monitoring of individual and population mental health using social media data. First, let me introduce our previous work on tackling mental health by integrating unobtrusive multimodal sensing. This is motivated by the fact that in ancient times, the only way doctors diagnose patients was through look, listen, question, and feel. Because there was no blood test, there was no medical imaging. Interestingly, this type of observation based diagnosis was not only used in China, but also used in Greece, as shown by this painting. I'm not sure how many people watched this movie, Terminator 3. It's a not a good movie. However, it contains a very interesting dialogue. Terminator, who's a robot, had this conversation with John Connor, the hero of the movie. The Terminator, he said, based on your pupil dilation, skin temperature, and motor functions, I calculated an 83% probability that you will not pull the trigger. Basically, John Connor got tired of running away from the killer robot. He wanted to take his own life and end the misery. But Terminator basically said, "You're not going to do it because I don't see it." So this was a science fiction movie, right? How did the Terminator do that? The Terminator had a vision, um, and and can also probably observe uh, John Connor's voice. But in any event, this is based on AI. Um, However, today we have turned science fiction into reality. Why did we do that, and how did we do that? We implement this technology to solve uh, the mental health problem. Mental health problem is a significant problem worldwide, and it's on the rise. Mental health problem also um, has many serious consequences, as listed here. However, the traditional methods of monitoring mental health are expensive, intrusive, and often geared towards serious mental disorders. So you cannot diagnose mental health problems by blood tests, by medical imaging. So the patient needs to see a doctor who will spend half an hour talking to the patient and observe the patient and finally figure out the mental health issues. So such a method obviously is not scalable, especially when we have large uh, section of the population having mental health issues. And such methods are also not very effective for people who are in the early stages of developing mental health problems. So it occurred to us about 5 years ago, we should try to use artificial intelligence to solve the problem. In particular, we're going to use computer vision, machine learning, and we're going to take advantage of the widespread use of internet and widespread adoption of social media. So our hope is to build a system that's physically non-invasive. Okay, we're not going to require the patients to wear some um, complex sensors on their heads or in their body, uh, but we want to help them monitor or manage mental health. This is the framework of our system. Basically, we're gonna rely on um, a device like smartphone or laptop, which has a camera. So the camera would provide us video signals that can help us find, analyze heart rate, head movement, eye blink, face expressions, and population pupil variation. Okay, actually, let me move the cursor in here. So video signals can give us these features, and then if we have access to people's social media content, we can also analyze the sentiment of these contents to know how people feel, how people think. We can also look at people's interactions with the device and with the content, and we use such activities to infer their mental state as well. So the key idea is we're going to extract a large family of um, psychobehavior signals. Okay, these signals can come from a variety of sources, but they come from mobile devices. Okay, and we also hope to access people's social media stream data, and then we can infer their mood and sentiment. Okay. In the end, we try to establish connection between mental health and all these signals that we can extract. Okay, and we want to do so through machine learning. These are just some examples of the signals we can extract. You can see some are noisy, some are a little bit better. I don't have time to go over the details, so please refer to our paper for details. Let me offer an example on how the system works. So this ground truth shows the um, sentiment or mood of a user, okay, while he's engaged in social media. And this is the prediction results using all the signals we can extract and machine learning. So you can see that the prediction follows the ground truth relatively well, okay? And if we refine the results using some temporal smoothing, such as HMM, hidden Markov model, then we can further remove the noise um, and have better prediction. So we've done two studies, one with a group of normal users. These are students and faculty members with various backgrounds. So our goal was to infer their sentiment status, positive, negative. So we can essentially achieve a accuracy of about 75% by F1 score. Okay. And a second experiment was done with depression patients. Using similar technology, we can infer their, uh, okay, we know they are depressed, but we want to know how depressed they are. So we can infer the depression levels at also roughly 70% accuracy. So ultimately, this is our hope. We're gonna build a physically non-invasive system, right? We're not going to put these scary sensors on people's head. And we hope that we can extract reliable enough signal. And of course, we can incorporate other sensors if they are available. So in the end, we hope to have a system like this to help people monitor their mental health conditions and manage their mental health conditions. And if needed, such information can be sent to doctors for informed intervention. Okay, let me move on to the second work where we try to recognize body languages in order to infer people's emotional and psychiatric conditions. So humans are very good at inferring emotions from body languages in person-to-person um, interaction. Folding arms in front of body signals disagreement, and putting hands on top of the head signals upset. Um, what we hope to develop was a system, computer vision system, that will take the input video like this basically records the interaction between patients and a caregiver. And then we are gonna first infer body language, next infer emotional status, and finally infer psychiatric symptoms. Okay, we have two challenges. One is it's very expensive to acquire such videos, so we only have limited samples. Second, we want to develop a system that is interpretable, because it's important for doctors to know why the system thinks uh, the condition of the patient is. Okay, so this is the framework we have developed. It has two parts. The first part would basically perform um, pose-based body language recognition. And the second part, we use, so this part is based on CNN and KNN. This part is based on RNN, where we use LSTM to infer from a sequence of body languages, people's emotional and psychiatrical conditions. Okay. So let me offer some detail. So we use open pose to get people's pose information. The reason we use pose-based recognition is it requires less data, right? Because we have uh, only a limited number of joints. We don't need to, you know, learn from the entire video. Okay, and because these things are not specific to a person, independent of the appearance and so on, uh, it has a better ability to transfer to other subjects. We also rely on, okay, so we take the coordinates of the joints and we convert them to a pose image, okay? And then on top of the pose image, we can easily use a CNN-based approach to perform recognition, okay? Again, I don't have time for details. Please refer to our ICPR 2020 paper, how we actually do this part, okay? And to recognize body languages, because we have very limited samples, we cannot use CNN to perform that part. Instead, we use KNN, K nearest neighbor classifier, to determine whether a given pose signifies a particular body language. Okay. So, and finally, we use LSTM to infer emotional states from body languages. Okay. Um, a little bit of information on the data set we collected. We collected 144 videos, and they were annotated for body languages and symptoms. That's our data set. And these are some numerical results. Basically, we compare our scheme with other viable schemes, and we show that we can achieve the best accuracy while offering interpretability, transferability, and we can do it with small data. Okay, this is for emotion interpretation. We also show that our system gives the better results. And finally, we use this system to classify two psychiatric problems, major depressive disorder and maniac episode. We were able to accomplish 80% accuracy for the task. Finally, let me talk about our most recent work on monitoring depression trends throughout COVID-19. The difference between this work and the two previous projects is now we're going to look at the problem at the population level. Okay, so in order to do that, we go to social media, Twitter, and we were able to construct the largest data set uh, to date, which consists of 25,000 distinct identified depression users. Okay, and then we're going to use transformer-based classification models and figure out the best um, classification model. Okay, and then we're going to fuse other information, including text features, users, demographic information, and other information, and we can perform further analysis for depression at the society level. Okay. Um, so, just a little bit of information on what has been done by others. So, some previous studies use language models of various kinds, but their work was based on very small data set with fewer than 500 users. This study used 1,400 um, depression users. But in our case, we created a data set of over 5,000 Twitter users. Half of them are depression users and half of them are control users. Okay. And then we investigate the performance of the state of the art language models, including BERT, Roberta, and XLNet. Okay. So first, we show that with a larger and larger data set, the performance of all the models can get better and better. Okay, so this confirms the value of our large data set. Okay, next we show that when we combine a rich set of features, we can do a better job at classifying depression. Okay, so we can use radar, demographics, engagement, features, personality, look. We can put all of these together, and we can. This is the accuracy we can get. It's almost 80%. So that makes it possible for us to analyze depression at population level. So we have two groups, remember? We have a depression group and non-depression group. And we look at the response of the two groups through COVID-19. It's very interesting that the non-depression group, the green curve, actually drops down really fast. These people got really depressed by the pandemic, but their emotion recovered as the pandemic went down. Okay, so after the U.S. national emergency and after last stay-at-home order, their feelings got better and better. In contrast, the response of the depressed users actually was slower. Okay, slower to decrease and slower to recover. So that's very interesting. And also the distribution of topics of the two groups are different. So these are different topics. You can see that the two groups are different in terms of their topics. Okay, and this is before the announcement of U.S. national emergency. This is after the announcement of U.S. emergency, national emergency. Depression levels are also different across the country. So there's New York State, California, Florida, and then the country as a whole. Interestingly, Florida is an outlier. It just shows, in terms of depression level, Florida is just a happier state um, than others. Okay. And then if you look across the states and then the country, uh, the distribution of the topics are also different. So let me offer some key insights for this part of the study. So we hope our results can guide policymakers in making more effective policies and strategies. Um, we discovered that the messaging from authorities is very influential and thus should be clear and well conceived. Um, um, we found out that more efforts of dissemination should be spent on socioeconomically disadvantaged groups who are exposed to potentially higher risks and already possess more polarized attitudes. Um, and accordingly, it's important to tailor the mitigating strategies for different demographic groups. Finally, let me offer conclusions for the entire talk. With these three sample projects, we show that intelligent monitoring systems have emerged in recent years to address mental health problems. Computer vision technologies are especially useful and are becoming more and more reliable for sensing certain aspects of affective states. Obviously, social media data is an important lens to assess mental health. And finally, multimodal fusion is expected to deliver robust solutions for monitoring mental health at both individual and population levels. Thank you for your attention.